In this video program, we hope to introduce you to the exciting world of pneumatics and its role in factory automation. If you're a student studying the Leaving Certificate Senior Technology course, you'll find the information in this video very helpful. Based on the electro-pneumatic training module, the course is designed to bring modern industrial pneumatic technology closer to those in the classroom. The simple composition of the training module, with its 3 different types of plates, along with the step-by-step learning approach of the tasks in the course manual, allows you to begin with the very basics of pneumatics and advance at your own pace through the different levels of automation to finally learn to master the programming of the PLC. The technology of the PLC is the basis of most of the automation in today's industry. So once you've passed each of the 15 different tasks of the training module and grasped an understanding of the PLC, you'll find that you will easily be able to understand the operation of the automatic machines, such as this, that are now commonplace in today's working environment. Before going any further in the explanation of pneumatic technology and its various different applications in industry, we would first like to tell you a little about ourselves. Telemecanique. Telemecanique is a worldwide force in automation and is particularly well known in Europe. Being of origin a French company, it has its headquarters in Paris. Here in Ireland, Telemecanique is well established, having a large factory in Selbridge, County Kildare, and a technical service branch in the Western Industrial Estate, Dublin 12. Our large variety of pneumatic products are only a small proportion of our complete control engineering product range, which covers in addition electromechanical and electronic products. The pneumatic products come in many different shapes and variations, each designed to fulfill a specific need in industry. For instance, each of these position sensors are distinctly different from each other, yet in essence they all do the same job. They sense the position of the pneumatic cylinder. And these stacking pneumatic power valves are just one of the many different types of valves available to industry. It can be difficult to understand why there are so many different variations of the same products until you look at industry and the machines which use them. Then you see how each pneumatic component has its own important role in contributing to the complete manufacturing process, assisting product preparation, assembly, packaging, or whatever the functions the machine might have. For example, this automatic screw-driving pick-and-place machine, just one of the many pneumatic machines in our own factory here in Selbridge. Outside of manufacturing, there's a whole range of Irish industrial sectors in which pneumatics play an essential role. For example, the meat processing industry. Pneumatics is just one of the 3 major automation technologies, these being electronic, electromechanical and pneumatic. The combination of all 3 serve to automate machinery and processes, whatever the products being produced. So, first of all, the word pneumatic. It simply means compressed air. In everyday life, there are many places where compressed air is used. Your local garage, for example, for simply inflating the car tire. That's compressed air or pneumatics at work. The same compressed air is also used in the garage to safely power tools and equipment, making life a lot easier for the mechanic, such as these paint sprayers and this pneumatic wrench, which enables the nuts to be removed from car wheels in a matter of seconds. In a similar way, pneumatics is used on the roadside and building site to assist work. The most popular of the pneumatic tools is this pneumatic hammer, also commonly called a jackhammer or Kango drill. It's a noisy but powerful tool. Just look at how easily it breaks up the concrete. Another reason pneumatics is used so much is because it's very safe. Imagine that yellow airline was an electric cable. It would be very dangerous, but with pneumatics it's safe. This portable diesel engine compressor provides the compressed air. If you take a look at the control panel, you'll see there's a small gauge which tells you the pressure of the air at which the tool operates. In industry, the use of pneumatics is even more common. All the movements on this machine are due to the linear motion of pneumatic cylinders. But if you want to see a good example of more complex pneumatics at work, take a look at this machine. All the actions of moving the product, sensing its presence, clamping it, lowering the screw driving head, they are all actions directly related to the linear motion of pneumatic cylinders. And notice these rotary screwdrivers, they are pneumatic too. Yes, a complicated machine, but it's only the beginning of pneumatic automation. This automated production line is fully automated. The items on the conveyor belt are withdrawn into processing machines and later replaced, having different shapes. The function of pushing the items on and off the conveyor is normally carried out by pneumatic cylinders. It's an example of the complexity of an automated system which employs electrical, electronic and pneumatic equipment. The machine is a reflection of man who designed it. Like man, the machine must be able to see, touch, read, measure. It must acquire data. It must memorize, compare, control. It must process this data. To allow you to build a small, fully automatic electro-pneumatic system of your own, Telemecanique have built this training module which uses the same pneumatic products as those found in industry. A variety of different standard pneumatic functions can be prepared using one of these basic pneumatic manipulation plates, along with the sequencer plates and the PLC plate. Over the next few minutes in this program, we will examine more closely each of these main components on the training module. Following that, there's a short live demonstration of 2 exercises. You should note, however, that this video is only intended as a supplement to the course manual, where all the subjects are covered in much more detail. The first component of the training module is the compressor, without which there would be no pneumatics. This is basically a pump which takes in ordinary air, compresses it, and stores it in an air reservoir or tank. The compression is of the silent type. A cross-sectional view shows you how it manages to seal in the noise. You can see its main components: the electrical motor windings, the shaft, the reciprocating piston, the valves, and the cooling coil. The compressor operates by taking in ordinary air, cleaning it through a filter, compressing it by the pumping action of the piston, and then passing it through a non-return valve to the storage reservoir. Compressors come in all shapes and sizes. This medium-sized portable is often used in garages, and this is the portable diesel engine compressor you've seen earlier. You can refer to the course manual. Compressors, reservoirs, air piping are all covered in more detail. Next, we see the products which use the compressed air, the first being pneumatic cylinders. These provide linear motion, which is used on pneumatic machines for elevation and indexing, gripping and forming, transfer, clamping, lever gripping, pivoting, rotation using the rack and pinion method, and for many other functions in manufacturing and assembly. Pneumatic cylinders come in many different shapes and sizes, all designed to fulfill a particular need, from small mini-cylinders to complete robotics. The modern cylinders have additional features which allow more effective operation and accurate control. In the interior view you can see on the piston rod the stronger lubricating brushes, the fluid-tight seals, the wiping gaskets, and on the piston head there's a lip seal gasket on each side and a permanent magnet in the centre for position sensing. To control the movements of the cylinders, there are many devices available. For example, these limit switches with the steel roller plunges, just one of the many types of direct contact position sensors. Where direct contact is undesirable, there are many other types of non-contact position sensors, for example, optical, magnetic, or capacitance type. In addition to position sensors, there are many other auxiliary devices which allow greater flexibility of control. For instance, these screw-on speed controllers, which operate by allowing free flow of air to the cylinder, but restrict the cylinder's exhaust air flow. These multifunction power auxiliaries, used for controlling and blocking, controlling and unloading, and many other functions depending on the setting of the particular plug-in device used. They are just a sample of the many auxiliary devices which allow flexibility of control of pneumatic systems. Next, we go from cylinders and their auxiliaries to the devices which control them. Power valves and control valves. Power valves have the functions of directing the flow of compressed air to pneumatic cylinders, pneumatic drills, and other power devices. They come as single standalone units or stacking versions which can be mounted on racks and neatly placed in cabinets such as this. The switching of the valve can be either manual or assisted by a combination of electrical and pneumatic means. On a cross-sectional view of the 5 two-way power valve, the same type as on the training module, you can see that the electrical solenoid opens up the flow of compressed air inside the valve, which in turn switches the position of the valve. On automated pneumatic systems, there are other valves known as control valves. Nowadays, control valves usually come in the modern form of modular sequencers, which are designed to be compactly stacked on racks. In the diagram, you can see that the sequencer controls the position of the power valve, which in turn controls the direction of movement of the cylinder. The sequencer plate on the training module allows the automatic control of the movements of 3 cylinders. It's the fact that the sequencer acts as a decision maker, like a type of pneumatic brain, which allows complete automation of pneumatic systems. In other words, total pneumatic automation. The more complicated a pneumatic system becomes, the greater the inclination is to have it electro-pneumatically controlled. It's by ingenious devices such as these, which convert compressed air signals into electrical signals and vice versa, that a pneumatic system, which would normally be controlled by a sequencer, can now be controlled by an electronic sequencer, or more commonly called a PLC. The PLC on the training module is a very powerful control unit and is used throughout industry wherever a high level of control is required. The same PLC is being used here in Dublin Airport to automatically control the operation of the circulating baggage conveyor system. The name PLC stands for Programmable Logic Controller, and it's a name you'll become familiar with as its popularity in industry grows. This example is just to show you how large a PLC can be. It's the PLC being used in Tarkett's Cushion Vinyl Flooring Manufacturing Company in County Westmeath. The PLC is linked up with a computer, and working together they allow an operator to have full control of a huge production line at the simple touch of a button. The computer monitor display shows the operator exactly what is happening along the production line. The operator chooses whichever display he or she wishes. For instance, this screen shows the line parameters and the position of the sensors. You might find it hard to believe, but the same high level of control and facilities of this large PLC are also available on the compact TSX17 PLC of the training module. At this stage in the video, we've covered all the major components of the training module. It might seem a bit complicated to you at the moment, but don't worry. To make it easier for you to get started, we'll show you two examples from the course manual. The first example is task number 5. It's a simple but classic example which shows the compressed air to the cylinder being switched through a 5 two-way power valve and the valve position being switched by push buttons. The second example is more complicated, task number 9. This involves connecting the sequencer plate and other valves in such a way so that the cylinders move in the sequence of A+, A-, B+, B-, C+, C-. This sequence can be represented by a graph set function chart. The picture shows how the same sequence would be used on a typical industrial machine. So, to begin on the examples, here's Claire from Telemecanique.
Hi, this is the equipment you're going to get very familiar with over the next 2 years. Altogether, the training hardware consists of 6 basic pneumatic manipulation plates, like these. A pneumatic sequencer plate and an electronic sequencer plate. This is commonly known as a programmable logic controller, or PLC. You can use the basic plates to perform any one of 15 basic exercises described in the training manual. Once these exercises have been carried out, you can then begin the more difficult tasks using either the pneumatic sequencer plate or the electronic sequencer plate. To help you get started, I'll demonstrate task number 5 from the training manual. To operate the cylinder, press push button A, the cylinder goes forward. Push button B to reverse the cylinder. Forward and reverse. So, having seen a relatively simple task, let's look at a sequencer task, task number 9. This simulates a simple pneumatic machine. 3 basic manipulation plates are required, as well as a pneumatic sequencer plate. It operates as follows. Press the push button. The pneumatic cylinders go in sequence. And once more.
So, this brings us to the end of our short introduction to pneumatics. We hope that you enjoy learning about pneumatics, and remember that the best way to learn is by plenty of hands-on experience, so take full advantage of the facilities of the training module. Again, don't forget to always consult the course manual, as its step-by-step approach helps you to absorb the information. If you are thinking of automation as a possible career choice, we can assure you that it can prove to be a very challenging career with constant change and new developments. As automation is the future of industry, there's sure to be a demand for engineers and technicians with good automation understanding. For those who are interested in learning more about automation, Telemecanique have a full range of technical literature on all automation subjects. So if you require any further information, please don't hesitate to contact us.